So it actually started, the idea, when I was 18 years old. I was like a little bit a hippie, let's say, and I was really fed up with all the garbage that you see at the streets, and I could not understand why humans do that. Why do we throw away all these plastics? We know that it comes into our environment, that it ends up in the sea, and that we are killing ourselves in the end. So that was very hard for me as a young guy to understand, why do we do that? And then I thought, okay, it's evolution, and people, we will grow, we will
grow smarter.
We will become smarter. We will know that we are killing ourselves, we will stop doing that. But then after 6 months already, I thought, no, that will not go that fast. So one day we will need to make robots to fix that. And from that moment, I started to think, okay, what can we do with all those robots? How will they have impact on our evolution of humankind? And especially, how can we grow in a good way, in a positive way with that? And I really started to create a vision where the Earth becomes a city in the universe. So where all the people live like a city in the universe, and then you have people that are working on getting our species out to other parts in the universe. But I think we really need to also work on the Earth itself and become a city of people. And we need a lot of work to make that sustainable, cost of people and planet again. So I started to think, wow, what can we do with robots? And it's amazing what you can do with robots. If you just a small example, our parents, our grandparents, they all had a vegetable garden, and we changed that to like mass production of vegetables. But if you know that only 60% of the food really ends up on our plate, and if you take into account how much traffic and damage to the environment it costs, it's really crazy that we have done that. So, but we don't want to go back where we all have to grow our own vegetables. I mean, some people do that because it's like a hobby and it's good for your mind, and it's great to do that, but not everybody, not the mass will not go back to that point. But if you have robots who do that, who grow your vegetable garden, then you are changing, you have a lot of impact in the world. And that's only a small example, and I thought about many examples, many things where we can have impact with robots. And I started to create that world in my head, but I also realized at that age that the technology was probably not ready for it, and myself, I was not ready for it. So I started to work on IT companies. I wanted to learn how to create technology products. My first company, I even failed with it. Then I had 2 successful companies, and like that I created a lot of baggage. And in my last company, our co-founder, Mike, became partner in that company. And one day we both had like a classical lawn mowing robot. We had one at the office also, so we had 3 lawn robots. And at the night or at the evening we were looking at it, and we were like, really, you cannot call that a robot. It drives 1,000 times against that same tree, and it still doesn't know there is a tree there. So you cannot call that a robot. And then I started with Mike talking about that vision that I had about robots, and we said, okay, let's sell our company that we have now and start making those robots.
All right, and that's how at the time Todi and today Eve became to be. Wesley, except for the electronics and some metal tidbits and also the screen, everything else, let's say, the biggest part of the robot is 3D printed. Now, talking with specialists, smart people, they say, nah, 3D printing, that's not for mass production. It's much more efficient and cheaper to go for injection molding. Mm-hmm. Why, or what is the fundamental reason for choosing 3D printing as an industrial production process?
Mm-hmm. There are actually 2 main reasons. The first one is actually linked to our mission in general. So our long-term mission is that we believe that we need to redesign the global supply chain, because today we don't take the cost of people and planet into account. So if you take, for example, our laptops, our smartphones, if you would take the real cost of people and planet into account, they would be very expensive. So that's a huge problem on the long run, because, well, for the planet, if we don't take the planet into account, we can actually kill ourselves in the end.
There's no more planet, so it's a bit of a problem.
That's a big problem. And if we don't take the people into account, that's also a problem, because if you look at global politics, you can see that the countries where we make our devices, let's say the low wage countries, they also want to get to the level of comfort that we are at, and we think they also should have this opportunity, because why can we claim to be the only persons who can have that level? But the problem is, if they want to rise up to that level, then there is a conflict, because our products are made based on the low wage countries. So that's really a conflict. So what do we think? We think that the solution there is that we need to introduce robots who can even work at a lower cost, so we can get to that level for everybody, and we can create what we call a world of abundance, so that the evolution can continue and that the people can grow, and that we also take the planet into account. So that's very important for us. And if you think about that, once you have robots that can do the work, then you will see a shift in the global supply chain, because you don't need to have your products made in China, because the cost is the same, because you have the robots working for you. So then we see a lot of activities that will come back to our country, to the local countries, and we will have local production. Now, if you want local production, you also need like a process that can manage that, and you want that process to be a sustainable process. So you want your resources that you use, you want them to be sustainable resources. So the way we thought about that is we really see the solution in additive manufacturing, they call it in the industry. It's what we call
3D printing, it's additive manufacturing.
Yes. So that's where we saw the solution for bringing that local production back and taking the cost of people and planet into account. So that's like one side of the story, why it's very important. Second side of the story is that if you think about robots in the future, in the long term, they will have to do thousands of different tasks. Now, they also need a lot of different tools to work with. If you want to have a flexible production system that can cope with all these different tools, all these different creativities that people will have, that they want their robot to do, you need a flexible production system. If you want, for example, a young guy who has an idea and he wants to create a tool for a robot, you don't want him to set up a factory in China with injection molding because of the cost, the complexity that it has to do that. No, you want a fast process where somebody just on his laptop can create a tool, he can print it, and he can make it and make it happen. So that's like the second reason why we are doing that.
So then the bright idea this young guy, girl, whoever, made and printed at home, let's say, can then be relatively easily transferred to an industrial additive manufacturing environment, so you can do, so that's then the idea, so that you can transpose that.
Yes, so we have guidelines to help that person, so it will be able to produce it in larger volumes. Now, another part of your question was, the experts say it's probably more expensive to do it with a 3D printing. Well, that's not correct. If you really calculate the price, you have to compare the right things with each other. So what the experts will say, they will say, look, if you do injection molding, you will do a series of 10,000 robots at once, and you compare that with the price of making one robot on a printer. But that's not right, because here you have mass volume, here you have one part. Of course, if you only make one part, it's more expensive, because the cost of your resource that you have to buy is more expensive because you only buy like 4 kilogram of plastics. While here with 10,000, yeah, you are buying 40,000 kilograms of plastic, and that's the difference. So the real cost is the cost of your raw material, which is the plastic, and if you buy it to put it in an injection molding or to put it in a printer, that doesn't matter. The cost stays the same. It's the volume that determines your end price.
So if you would print 10,000 pieces, your material would also be cheap, and
Yes,
in the end it would.
yes.
And,
Actually, the machine cost of the injection molding or the printers, you can neglect that. That's why they say you have to make 10,000 parts, because that price of the machine is neglectable, and it's the same in printing.
Okay.
It comes down to your plastic. And then the main advantage of printing is that printing is already made for sustainable raw materials, while in injection molding, that's still new. They're still experimenting with it because it has different temperatures to bake your product, and those machines are not made for it yet. So that's all new, and they still don't have a very good process to use sustainable raw materials in that.
Okay, so talking about those raw materials, that was an explicit question of one of our, dare I say, favorite customers. We love all our customers, obviously, but Luc Dekens is one of the early adopters, and he's appeared in some movies from us already. And he was wondering, he had a number of questions. One of them was, how about this eco-friendly material? So we're claiming that. What does that mean? Why is it eco-friendly?
It actually comes down to being durable, sustainable. And what do I mean with that is, if you take plastics that are made from oil, it takes a long time, like 100,000 years, before nature turns into oil. While if you have, like what we are doing, we are using plastics that can be made of corn or beets, and if you have that, you can grow them every year. You can keep on growing them. So that's why it's a durable material.
Yeah, so it's non-petrol based material.
It's non-petrol based, and we also search for the corn that is grown without pesticides and things like that. So
maybe one day the willows will be able to grow their own corn.
Yes, that's our vision in the long future, in the long term, that they can grow their own corn, that they can harvest it, that they can turn it into plastics, that they can feed it to the printer, and that they can make a new sister robot.
That would be, it's a wonderful vision, let's say that.